Welcome, focused learners. In this explainer, we're going to push right past the usual buzzwords to understand the actual mechanical differences and structural trade-offs between REST and GraphQL. We aren't just going to talk about theory today. We're going to visualize exactly how these two data retrieval titans operate under the hood, side by side, so you can engineer better systems. Okay, let's dive into this. Here is our structural roadmap for today. First up, we'll establish a core visual metaphor. Second, we'll contrast payload precision against data bloat. Third, we're doing a caching reality check. Fourth, we'll look at evolution and versioning. And finally, we'll synthesize everything into a final decision matrix. Starting with Section 1, Structure, GraphQL versus REST API. Before we even look at network packets, we really need to ground these abstract HTTP concepts into a tangible, physical reality. We've got two heavyweights entering the ring today. On one side, we have the REST API. Introduced by Roy Fielding way back in 2000, REST isn't actually a tool. It's an architectural style that leverages standard HTTP protocols as its communication interface. On the other side, we have GraphQL. Developed by Facebook and released in 2015, GraphQL operates a bit differently. It's actually both a query language for your API and a runtime for executing those queries against your data. But the biggest difference between them is exactly how data is sent to the client. To truly understand this structural difference, think of REST as a sprawling town with multiple separate shops. REST uses a fixed set of endpoints. So if you're building a user dashboard, you literally have to drive to the user store to get the profile, then drive across town to the post store for their content, and then drive all the way to the follower store to get their network. The client makes multiple HTTP requests and gets multiple HTTP responses. It's very rigid. GraphQL, however, is like a massive logistics hub. It uses just a single endpoint. You walk up to one desk, hand the worker a highly specific custom checklist, and they run to the back, pick exactly what you asked for, and hand you a single custom bento box in one trip. Moving right along to Section 2, Data Fetching Precision versus Bloat. Let's shift our focus to data fetching mechanics and visualize what those actual network packets look like in transit. In a REST town, because those endpoints are totally fixed and prepackaged by the backend, we run into two major pain points. First is overfetching, which means receiving way more data than you actually need for your specific use case. The second is underfetching, where the endpoint gives you less data than you need, forcing you to make all those multiple round trips we just talked about. And this brilliantly illustrates the real-world cost of that architecture. Imagine a UI that just needs a user's first name. You hit the endpoint, but the REST server returns this massive payload: email, address, birth date, status, password hashes, 50 fields of data. Watch as those 49 unused fields essentially drop straight into a trash bin. It's completely wasted bandwidth and processing power. Contrast that with GraphQL Precision. Using a single request, you ask for exactly what you need, just the first name. That exact field instantly populates in the response JSON, zero waste. For clients dealing with a large number of small, specific requests, this surgically reduces the data transferred over the network and heavily improves your efficiency. Section 3, Caching, the reality check. Now, it's super easy to look at that precision and think GraphQL is just pure magic, right? But we need to pivot for a second and look at the under-the-hood trade-offs. Mechanically speaking, while REST relies on standard HTTP methods like GET, POST, PUT, and DELETE that map to specific endpoints, GraphQL relies almost entirely on a single POST request for all its queries, mutations, and subscriptions. Because REST responses come from specific, unchanging endpoints, they can be cached so much more easily. This reduces the number of requests made to the server, which dramatically improves performance. When it comes to caching, the reality is stark. On the REST side, a browser or a CDN can effortlessly intercept a simple URL request with a bright green 200 OK cache hit shield, serving the data instantly without ever even touching your backend database. But on the GraphQL side, because the response is uniquely tailored to every single request and funneled through one POST endpoint, it's fundamentally way more difficult to cache. The caching engine literally has to parse deep inside the JSON body just to figure out what's being asked. Plus, imagine a malicious or even just an accidental nested query, asking for a user, then their friends, then those friends' friends, and so on. Without proper safeguards, you can literally watch your GraphQL backend server turn red and heat up under the weight of an incredibly expensive execution graph. All right, Section 4, Evolution and Versioning, Adapting to Change. Moving past performance, how do these two architectures actually handle growth over time? How does this all play into long-term maintenance? Well, in a REST API, when the shape of the data changes, like, say, adding a new field or restructuring a resource, it typically requires a whole new version of the API, usually implemented by creating a completely different URL. This makes API evolution pretty hard. You have to maintain version 1 while pushing version 2 just to make sure existing clients don't break. GraphQL APIs, on the other hand, don't require versioning in the same way. Because the client is explicitly requesting any combination of fields it wants, you can just add new fields and types right to your schema. Old clients keep asking for the old fields, and new clients ask for the new fields. The API evolves far more flexibly without breaking a thing. And that brings us to Section 5, Conclusion, Choosing Your API. We've looked at the physical metaphors, the payload mechanics, the caching realities, and the evolution. Now let's synthesize all of this to help you choose the right tool for your next build. You should absolutely choose the REST API when your application domain is straightforward. If you're building simple resources or standard CRUD applications, meaning create, read, update, delete, REST is phenomenal. It's also the undisputed champion if your architecture heavily relies on native browser caching to save server load. Finally, if you're building a public third-party API where you really need predictable, standardized, and strictly controlled access to your resources, REST is incredibly reliable. So, the crucial point is, you switch to a GraphQL API when you hit very specific friction points. If you're building a highly complex UI or working with mobile networks where bandwidth is super constrained, that zero-waste payload precision is just invaluable. It's also ideal when you need to pull data from multiple different sources or microservices into a single request. And finally, if your front-end teams require rapid iteration and want to evolve their UIs flexibly without constantly waiting for back-end engineers to build new, specific endpoints for them, GraphQL provides that exact freedom. Look, both are incredibly useful tools, and the efficiency of either API depends entirely on your specific needs and use case. So I leave you with this final provocative thought for your engineering team. Will your next application function best as a sprawling metropolis of predictable, easily cached storefronts, or do you need the surgical precision of a single, highly optimized warehouse? The choice is entirely yours.